Designing a structure that can withstand a major earthquake requires detailed knowledge of how it will react when the ground beneath it shakes. But researchers can't just wait around for an earthquake to hit to test a building's resiliency. In Japan, they don't have to. After a near 7.0 magnitude earthquake rocked Kobe City in 1995, the government of Japan decided to construct an enormous earthquake testing facility named E-Defense. Inside the facility sits the world's largest shaking table. Measuring 15 by 20 meters, powered by 4 immense engines, and able to support 1,200 tons in weight, the massive table reproduces the three-dimensional ground motions of major earthquakes, allowing researchers to test full-scale buildings to destruction. To perform an experiment, a carefully constructed building replica is hoisted onto the table using a pair of giant cranes. Once positioned, the replica is subjected to shaking motions that imitate the direction, displacement, speed, and frequency of past earthquakes. Since its completion in 2005, the table's been used to test everything from the drift of high-rise buildings to hospital design. Some of the first experiments looked at how retrofitting can protect existing structures from collapse. Replicas of houses and schools with and without seismic retrofitting were tested side by side as the table simulated the ground motions of the 1995 Kobe earthquake. The results clearly showed that the retrofitting was effective at protecting the structures, creating a strong push to update buildings across Japan. Use of E-Defense is not limited to researchers in Japan. The facility is open to researchers from across the world. For example, one collaborative project that's been ongoing for the past decade with the United States is to test various structures similar to those found across America. The data gathered from such efforts have been publicly released to help researchers around the world fuel their own work looking at building design. During its decade-plus of activity, over 80 large-scale tests have been conducted through E-Defense. Although the facility is still working on updating testing methods and sensing techniques to perform more complex experiments, the data collected thus far have been critical to supporting safer, more resilient construction across the world.